Assalamu alaikum, ladies and gentlemen. Greetings and warm wishes for the day. Considering how amazing the current aviation industry is, I wonder how rich and astonishing its history would have been. One miracle of the aviation history is this DC-3 that was the pioneer of commercial passenger airline services. I'm Aisha Khatri from Basler Turbo Conversions. We are a USA-based private company and we have been manufacturing and rebuilding the DC-3 since 1990. I'm here to present to you the most recent retrofit we are working on, that we're currently working on. It is focused on the use of synthetic aperture radar for terrain mapping with the purpose of search and rescue and reconnaissance. Here is a word from our founder. I had already discussed its history and specs in my first presentation. Let me quickly walk through them. Originally manufactured by the Douglas Aircraft Company, the DC-3's first prototype flew on December 17, 1935. It is remarkably robust and rugged. It was the first plane to land on the South Pole in October of 1956. Designed to carry a maximum of no more than 30 passengers, in Burma during the war, it somehow managed to board a total of 74 and is also believed to have carried 93 flood victims in Brazil. By 1993, more than 90% of the nation's airline passengers were flying on DC-3s. During the war, though, they were adapted for transportation of troops and cargo. These extraordinary characteristics of DC-3 were the inspiration behind retrofitting it with modern systems for efficient search and rescue and reconnaissance. 184 models of DC-3 are still active today. These models are mostly owned by America and Canada. Since the DC-3 was designed and built during an era when avionics technology was significantly different from what we have today, its avionics systems are quite basic compared to modern aircraft. It did not have advanced fly-by-wire or digital bus architecture found in modern aircraft. As it can be seen in this image of the cockpit, most of the indicators were analog and mechanical. Communication and navigation systems were also limited to classical methods. Synthetic aperture radar is the heart of this retrofit, equipping the DC-3 with advanced imaging capabilities. Accurate and precise imaging and terrain mapping are essential not only for reconnaissance but also for search and rescue operations to correctly locate the desired area. The synthetic aperture radar operates by transmitting microwave signals towards the ground and capturing the reflections. The importance of SAR in search and rescue and reconnaissance lies in its ability to provide detailed, high-resolution images of terrain, detect surface movements, and identify objects whether fixed or in motion. The SAR antenna is placed on the belly below the aircraft. This placement ensures a clear view of the ground and allows the SAR system to effectively capture the radar signals that return during the flight. It is placed in an external pod that is attached to the aircraft. The pod contains the SAR antenna and its associated electronics. The SAR image on the cockpit display presents a critical visual aid to the pilots during search and rescue and reconnaissance missions. The high-resolution display provides real-time detailed imagery of the terrain below, aiding in the identification of targets, obstacles, and changes in the landscape. The second aspect of this retrofit is installation of GPS navigation. GPS technology enhances the aircraft's navigational accuracy and communication capabilities, crucial for both search and rescue operations and reconnaissance missions. The GPS navigation system allows the DC-3 to accurately determine its location and navigate through various terrains. Operating through a constellation of 24 satellites, GPS provides real-time position information, improving the aircraft's ability to execute precise routes, waypoint navigation, and effectively reach target areas. The GPS antennas are placed on the tail fin of the DC-3. This placement maximizes satellite signal reception by maximizing the antenna's exposure to the sky while minimizing potential interference from the aircraft's structure. The output from the GPS system is presented on LED screens in the cockpit. Pilots have real-time access to critical navigation information, including the aircraft's current position, planned route, waypoints, and other relevant data. Here is a comparison of the old and the modified cockpits. With SAR and GPS technology, the DC-3 can now operate efficiently in day and night, irrespective of weather conditions, significantly broadening its operational envelope. This is it from the avionic aspect of the retrofit. Since this retrofit is focused on search and rescue operations, the aircraft must have the ability and flexibility to land on all kinds of otherwise inaccessible and remote areas. Although this is not an avionic system, it would be very useful in increasing the versatility of the aircraft. And this is the installation of floats and ice runner landing gears. That is why this structural modification is part of the future plan. The float and ice runner landing gears are crucial for search and rescue missions involving the Douglas DC-3, especially in maritime or icy environments. The float landing gear enables water landings, allowing the DC-3 to search remote locations, rescue survivors at sea, or respond to maritime emergencies. In contrast, the ice runner landing gears equips the aircraft to operate in icy or snow-covered regions, expanding its versatility during search and rescue operations in challenging weather conditions. These specialized landing gears enhance the DC-3's adaptability, ensuring it can effectively respond to emergencies across diverse terrains, making it an invaluable asset in comprehensive search and rescue missions. This is part of the future plan. The current retrofit is only limited to the SAR imaging and GPS navigation. This is it from my side. Thank you.